So we want to take a look at locating rational numbers, specifically on a number line. So we want to remember rational numbers are our integers, our wholes, our natural numbers. So that -3, -2, -1, 0, 1, 2, 3, 4, plus our fractions and decimals, right? So anything that's terminating or repeating, all right? So we're going to go ahead and do this by using our calculator to convert most of these numbers to a decimal. All right, so growing up, we have used decimals a lot more than we have fractions to express a number. So if I say the number, say 6/2, you're more used to hearing that as 3. Or if I say the number 5/3, you're more used to hearing that as approximately 1.6. And we're able to locate these numbers on the number line easier if we have them as decimals rather than as fractions, because that's what our brains are used to dealing with. So the first thing we want to do when we're locating these numbers is to convert them to their decimal form. So take a moment and in your calculator, type all of these numbers in example 1 and grab them as a decimal. So I'm going to do the first one, 3/5. So we could put that in as a fraction, or we can express that as 3 divided by 5 as well. So we're going to put that in, and we're going to see that that is the decimal 0.6. And I would suggest rounding out to the hundredths place. So that's 2 decimal points after the decimal. So take a moment and go through and do all of those. Okay, so taking a look, I wrote the decimal version rounded to the nearest hundredths place for all of these values. And now we're going to start placing them on the number line and labeling them with their appropriate letter. So if we're looking at 0.06, 0.6, we know that that number is going to be in between 0 and 1. Now we're just doing approximations, but we want to do a good approximation. So if I think about 0.6 or 0.6, will it be closer to 1 or will it be closer to 0? So we want to think that in between we have at least a halfway mark, and we want to make sure that we're at the very least on the correct side of this. So in between each of those numbers is always going to be 0.5. So there we have 0.5. Here we would have 1.5, 2.5, and so on all the way up the line. So if I'm thinking about 0.6, well, 0.6 would be bigger than 0.5, so I want to be on the right-hand side of 0.5 there. So I'm going to go ahead and put my mark right there for A. Right? So again, this is approximate. It's a small number line to draw on, but you just want to make sure that you're putting it in a location that makes sense. I don't want to put 0.6 right next to 0 because it's closer to 1 than it is to 0. Not by much, but a little bit. So 3.25. So if I think about that, well, it's going to be under the halfway mark and by a good bit. So it's going to be a lot closer to 3 than it is to 4. Okay. Now, the negatives. Sometimes these can get a little tricky. So -1.2. That's going to be in between -2 and -1. And we kind of have to think about the negatives in reverse. So right here, we would have -1.5 right in the middle. So when we want to decide what side this is going to be on, we almost want to ask ourselves, is it closer to 0? So -1.2 is closer to 0 than -1.5 is, because remember, it works a little bit in reverse. So that means it's actually going to be on the right-hand side, closer to -1. So it's going to be over here. That's where we're going to put our C. Okay, so let's keep going. 4.75. So that's in between 4 and 5. 4.75 is closer to 5 than it is to 4. That's going to be our D. negative 4.38. So that's going to be in between -4 and -5, and it's going to be closer to -4. So we just want to make sure that we're on the correct side of that halfway mark at the very least. So that's going to be our E. And then F, 8.08. So that's in between 8 and 9. And that's like really close to 8, right? Really close to 8. So there's our F. So now we have all of these identified and labeled on our number line. Okay, what if we wanted to do this in reverse? What if I was given a point and said, hey, what fraction could represent that point? Okay. So there's a couple different ways to go about this. And I'm going to give you kind of the easier way first. So our brain works better in decimals than it does in fractions. So we're going to let it do that. We're going to let it work in decimals. And I'm going to say, all right, well, let's look at D. So D is almost right in between 1 and 2, right? Maybe a little bit closer to 1. So I'd say, oh, if this was a decimal, it might be about 1.4. Okay, it might be about 1.4. So we can use our calculators. You can take 1.4 and type it in there. And then right above your enter button, there's a little double arrow. You can click that, press enter, and it's going to say, oh, well, 1.4 is 7/5. Well, there's a rational number, 7/5. So I can say, well, D is approximately 7/5. But how else could we do this? And this would be a bit of a quicker way because typing all of this into the calculator takes time. So we can remember that we can change what numbers look like without changing their value. So I want to write all of these numbers on the number line as fractions without changing the value. And the easiest fraction to deal with is where our denominator is 10. So I'm going to do a little side work up here. And I say, okay, how can I rewrite the number 1 as something over 10, right? 1 is equal to what divided by 10? So if we remember from multiplying fractions, if we have this, we can multiply the numerator and denominator by the same number. So 1 is really a fraction, right? We can put any whole number over 1 or any integer over 1. So what if I multiply that by 10 over 10? Well, 1 times 10 is 10. 1 times 10 is 10. Okay, well, what if I did this for 2? Multiply 2 by 10 over 10. Well, that would be 20 over 10. And maybe we're starting to see a pattern. So what I'm going to do is I'm going to rewrite this entire number line using fractions. All right, so instead of 1, I'm going to write 10 over 10. Instead of 2, I'm going to write 20 over 10, 30 over 10, 40 over 10. We're going to leave 0 as 0 for now, or we can really say 0 over 10 if we want. Negative 10 over 10. And you continue this trend all the way down the number line. Okay, so now we have this written out. So how can we use this to help ourselves write these fractions? Well, let's take a look at E. So E is between 30 over 10 and 40 over 10. So essentially what I want to do is pick a fraction where my denominator is 10 and my numerator is in between 30 and 40. And if I look at E, I want it to be closer to 30 than to 40. So maybe I'd say 33. And I always want to check if I can reduce, and I can't for that one. So let's take a look at F, because that's nearby. So we're in between 40 over 10 and 50 over 10. So we know we're going to have a denominator of 10 here. And we know our numerator is going to be in between 40 and 50. So maybe that's about 42. And again, we're being approximate. So you want to be in the general ballpark of where I am. And this one, we can reduce. So we want to reduce if we can. That's a general rule at all times. So this would be equivalent to not 41, 21 over 5. And we can do this for the negatives. So C is in between negative 10 over 10 and 0 over 10, but that C is closer to negative 10. So maybe it's like a negative 7 over 10. B, you might approximate as maybe negative 28 over 10. And again, that's reducible to negative 14/5. And then A, okay, so we're again going to be over 10, but we need to be in between negative 50 and negative 40, but a little closer to negative 50 there. So maybe we're at 58, excuse me, negative 58. And that is reducible. So we want to go ahead and reduce whenever possible to get a negative 29/5. So there's a couple different ways to do this. Pick which one works best for you and go with that.